CCIEORDIE.COM, I'm Artec, and this is CCNP Switch 300-115 1.5C Load Balancing. This section is called Load Balancing, but let's first talk about traffic distribution in ether channels. They're similar yet different. Traffic distribution in ether channels simply describes the percentage of utilization of traffic across the links, whereas load balancing allows for a method of manipulating the traffic across those same links. A hash algorithm is used to set forth the rules by which the ether channel distributes its traffic. The hash is based on an XOR operation determined by the rightmost or least significant bits. At least it appears to operate that way with the Cisco algorithm. In a two-port ether channel, you should be able to determine which link will be selected for use. If the MAC or hex addresses end in binary numbers that are equal, for instance 0 and 0 or 1 and 1, the XOR result is 0. Otherwise, the XOR result is 1. If the XOR is computed to 0, the first link is supposed to be used, and if it computes to 1, the second link is supposed to be used. The fact is, the algorithm for this determination is Cisco proprietary, and you're going to be hard-pressed to get a definitive answer as to how it actually works. If you figure it out, please let me know. I can tell you that, in theory, if the hex or IP addresses for the comparison of both sides computes to even numbers, for instance, A in hex is 10 decimal, which in turn in binary is 1010 ending in 0, it's supposed to use the first link. If one is odd and one is even, 0, 1, it will favor the second link. That is the theory anyway. It's easy enough to get references on both ratios and percentages of traffic, as these examples show, which I have here. This is percentages, a percentage table based on the amount of links that you have bundled, and these are the ratios of said links, depending on how many you have bundled. Okay, so let's go to switch 1 and make some ether channels. Config T interface range F0/23 to 24 channel G1 mode active, and we'll go to switch 2. Config T interface range F0/23 to 24 channel group 1 mode active, LACP on both sides, and we'll go to interface PO1 and switch port trunk NCAP.1Q. This is the preferred method, by the way. Switch port mode trunk. Now we'll get the other side. Interface PO1 switch port trunk NCAP.1Q. Switch port mode trunk. And if we go back to switch 1 and do show ether channel sum, we should be layer 2 up, and we're using LACP, and FA0/23 and 24 are bundled, and that's great. So let's end here. And now we can test the links. If we look, let's look here at show interface F0/23, and we'll get the MAC address. Let's right here. Notice it ends in 9, and we'll copy that and Control C. So from the command line, we're going to test ether channel load balance interface F0/23 interface port channel. All right, we'll do 1. Okay, and we'll do MAC, and we'll get the hit under there, and then we'll show interface PO1, and we'll get the MAC directly from the PO1, and there it is. It ends in 0 because it's A or 10. Copy and Control C, and we'll bring it back up. We'll add that one. Paste. And now we'll get it from do show interface PO1 over here. And this one ends in a 0 as well. Copy, paste, and we'll see what it says. It's supposed to select the first one, or link 0. So that's something you can test out yourself. I've tested out a number of times and I get a mixed bag of results. Anyway, thanks for watching. That's Etherchannel load balancing, at least Cisco's implementation of it.